Okay, so this is the drawing for the hyperbola using the eccentricity method. Alright, again, we discussed in some of the earlier classes that the eccentricity for a hyperbola has to be greater than 45 degrees. And in this case, we're told that the line of eccentricity is a ratio of 6 to 5. Okay, and if we look at how we plot that, basically the top of the fraction is the distance from the focal point to a point on the curve, and the number at the bottom is the distance from the directrix to a point on the curve. And it can be any multiple of this fraction. So I'm making it life a bit easy. I'm just putting a 0 after both of these numbers. So I'm going to have a line that is has measurements of 60 and 50 on it. So we're going to look at how to do that. It should be 60 from the focal point to point P, and it should be 50 from the directrix to the point on the curve. Okay, so let's zoom back out there a little bit, and we're going to plot that. So what I'm going to do is, along my axis, I'm measuring out 50 millimeters, which, as you can see, I have that line there already. I'm just going to mark it in here again so that you can actually see it. So that's my 50 millimeters. And then I'm going to measure 60 millimeters up from there. So from that point, measuring up 60 millimeters, and that's going to get me my point P. Alright, now the way to check that is if you draw your line of eccentricity from where the axis crosses the directrix up through the point P, it should be greater than a 45 degree angle, like I mentioned. So lining up the set square, whoops, there we go. Alright, you can see lining up the set square, the angle is more than 45 degrees from the axis, which means we're correct there. Alright, have you all got that much set up? Yeah. Okay, have you